Hi, welcome to Sacham Study Tech. Today topic is mid sort. Mid sort is a sorting algorithm that follows the divide and conquer approach. It works by recursively dividing the input array into smaller subarrays and sorting those subarrays, then merging them back together to obtain the sorted array. So the time complexity of the mid sort is big of n log n. Auxiliary space is big of n. So now we can discuss the algorithm of mid sort. So algorithm mid sort low comma I. That means that array consisting of more than one element. For example, this is a A array consisting of more than one element. For example, here it is 2 and 8 and 6, 4, 3 and 1. Here it is 7. So these are the number of elements is there in that array. Here array index starts with 0 and 1 and 2, 3, 4, 5, 6. So total 6 elements is there. 0 to 6, that's 7 elements is there in that array. Now we can see low less than I. So low value is 0 and I value is 6. Then mid, you can find out the mid element. You can, this entire array is divided into two subarrays. So mid equal to low plus I by 2, that is mid sort, low to mid, and mid sort mid plus 1 to I. So here it is mid equal to 0, that is the low, plus I, that is 6 by 2. Floor value here it is mid equal to 6 by 2, that value is 3. So this entire array is divided into two subarrays. This left subarray consisting of low to mid, so n by 2 elements is there. Here also n by 2 elements is there. So here it is merge low, mid, I. So you can merge these elements, these two subarrays. So n comparison is needed. So that's why you can write the time complexity of the merge sort is T of n equal to 2t n by 2, two subarrays n by 2 plus n by 2, 2n by 2 plus n number of comparison is needed. So you can see here this subarray consisting of 2, 8 and 4 and 7. So that is 0 to mid, that value is 3, up to you can take the 0 to 3. Here it is mid plus 1 to I, that is 4, 5, 6, 3 elements is there. Element is 6 and 3 and 1. So here also more than one element is there. Then you can recursively call this function again and again. Here also. So here this subarray is divided into two subarrays, that is 2 and 8. Here it is 4 and 7. 4 and 7. Here also more than one element is there. So the array is divided into two subarrays. 2 and 8 is there. Here it is again divided into two subarrays, because this is a big problem. So by using divide and conquer strategy, so you can divide this entire problem into sub problems, then each and every sub problem you can solve it. So that's why. So here it is a small problems. Then in right subarray also you can divide it into two subarrays, 6 and 3. Here it is one element. Here also more than one element. Then it is divided into subarray 6, 3 and here it is 1. Now you can merge. So how can merge these elements? Later I can explain here. First you can see merge these two. Okay, stored in sorted order. Here it is 2 and 8. it is 4 and 7, 4 and 7 here. Okay, and then merge these two lists. Left subarray, store the sorted array. Here it is 2 and 4 and 7 and 8. Here also 6 3, that is 3 6, 3 6 and 1. Here it is 1 and 3 and 6. Now two list is there. Now we can apply the merge. Now I can explain here 2 4 7 8. So this sub list consisting of 2 4 7 8 and right sub 136, right sub array is consisting of 136. Now you can see here it is a it is a low, it is the low, it is mid, it is low and it is mid. Here it is indicates the mid plus 1. Here it is high, it is low, it is mid. So I am consider t equal to 1. I am taking one variable t equal to low. So low value is here, it indicates, for example, here it is 0 and 1 and 2 and 3. Here it is 4 and 5 and 6. Total 7 elements is there. So this is the array. So t here indicates, here it indicates the t. Here it can indicates j. I am taking one temporary array for storing these subarrays in sorted order. That's why I am taking one temporary array. So the array name is B. Here indicates the I. Here indicates the I. Now we can see t less than or equal to mid. So t less than or equal to mid s. So that is 0 less than or equal to, what is the mid here? That is 3. So 0 less than or equal to 3. The condition is true. And j less than or equal to I. So what is the j? 4. So 4 less than or equal to I. What is the value of I is 6. So both the conditions are true. Then resultant is true. Then if a of t less than or equal to a of j. So then you can compare these two subarrays. A of t. So what is the value of a of t? A of t value is 2. So 2 less than or equal to a of j. What is the a of j value is 1. A of j value is 1. 2 less than or equal to 1. Okay. The condition is fail. Now the else block is executed, that is b of I equal to a of j. So what is the b of I? B of I equal to a of j. What is the a of I? A of j value is 1. So a of j value is 1. 1 is stored here in b of I. So j is incremented. J is indicates here. J is incremented and I is also incremented now. Then again you can compare with a of t and a of j. So a of t value is now it is 2 less than or equal to, what is the a of j value is 3. 2 less than or equal to 3. The condition is true. Then if a of t less than or equal to a of j, the condition is true, the b of I equal to a of t. A of t value is 2. Now 2 is stored in b of I. So here. So then t is incremented. T is incremented. 0 plus 1, 1 here. And I is incremented. Now I indicates here. Again you can compare with a of t and a of j. So a of t value is 4. 4 less than or equal to, so a of j value is 3. 4 less than or equal to 3. the condition is fail, then else block is executed, b of I equal to a of j. So what is the a of j value? 3. So 3 is stored here in b of I. 3 is stored here and j is incremented. So j indicates here, this is j, and I is incremented. I is incremented. Now here a of t less than a of j. A of t value is 4. 4 less than or equal to a of j. A of j value is now 6. 4 less than or equal to 6. It is true. Then a of 4 less than or equal to 6. It is true. So b of I equal to a of t. B of I equal to a of t. A of t value is 4. The 4 is stored here. Then t is incremented. T is incremented now. And I is incremented. Now we can see it is 7. 7 less than or equal to a of j. A of j value is 6. 7 less than or equal to 6. The condition is fail. Then b of I equal to a of j. Then 6 is stored here. And j value is incremented. J value is incremented. Okay, that means here there is no elements in that right subarray. All elements is completed. Okay, then I is also incremented. Now I indicates here. Now here you can see 7 less than or equal, there is no elements here. Now we can check here, the condition is t less than or equal to mid. T less than or equal to mid, the t value is, now the t value is 2. So 2 less than or equal to mid. So mid value is 3. The condition is true. Okay. Now you can check the second condition. J value is now 7. So j value is 7. 7 less than or equal to I value is 6. The condition is fail. So where you can close that, here while loop is closing, then skip this body of the while loop here. Now we can check t greater than mid. So t value is 2 greater than mid. So t value is 2 is greater than 3. 2 greater than 3. If the condition is true, what is the meaning of this 2 greater than 3? So if the condition is true, that means only left side elements is there, left subarray is there, then all the what are the elements is there in right subarray, right subarray elements is stored directly here in the resultant matrix. Okay, that is the meaning. So for example here it is fail, but if it is true, then k equal to j, what are the elements is there, that you can assign to j, and up to j up to I. So all elements is stored in that b of I. Okay, but in this case it is fail. Now else block is executed. What is else block? So what are the elements is there in left side? So those elements is stored directly here. So how many elements is there here? It is 7 and 8 is there. So directly can store here. Okay, then after that, what are the elements is there in temporary array B, that all elements is stored in A. So that is the statement here. You can see for k equal to low to I do, A of k equal to B of k. So what are the elements is sorted elements is there in that B of k. All elements is again you can store into the original array. So that array is sorted array. Okay. Now the recurrence relation of this merge sort is Tn equal to 2Tn by 2 plus n. So for example here only one element is there, T of 1 equal to only 1. Okay, need not to divide that problem into sub problems. That is a small problem, you can solve directly. But here 2Tn by 2, the entire array, if more than one element is there, n greater than 1, then more than one element is there in that array, then that array is divided into two subarrays, n by 2 plus n by 2, that is 2Tn by 2, 2Tn by 2 plus n number of comparisons. Okay, so here it is recursively you can call the same function here. 2, here n is there, you can write here. So in place of n you can substitute n by 2. So now in place of n you can substitute n by 2. So 2t n by 2 into 2, that is n by 4, plus this n, that is n by 2, that is equal to 4t n by 4 plus here the 2 into n by 2, that is n, plus here also n is there, that is 2n. Again you can call the same function. Here it is 2n, you can write here in place of n by 4 you can substitute n by 4. So that is equal to 2t n by 4, that is n by 2 is there, 2 into 4, that is 8, plus n is there, in place of n by 4 is there, you can substitute it. So here it is 8t n by 8 plus 4 into n by 4, that is n plus 2n, that is equal to, so you can write 8 2 cube t n by 2 power 3 plus 3n. So you can call the k times the same function, 2 power k, 2 into t of 2 power k plus kn. Now you can see if you can apply the same thing recursively, you can call the same function, that you can, that array is divided into subarrays. In certain time that subarray consisting of only one element, okay, that is t of 1 equal to 1. Now here it is n by 2 power k is, let n by 2 power k in certain time that value is only one element is there in that subarray. So you can write n equal to 2 power k. You can apply the logarithms on both sides, that is equal to log n equal to k log 2. So here the log 2 base 2 value is 1, this value is 1, so the k equal to log n, k equal to log n. So here the 2 power k, that 2 power k value is n. Here either n equal to 2 power k or 2 power k equal to n, so n by n or 2 power k by 2 power k, that is 1, t of 1 plus what is the k, k is log n, so here also n is there, so n in place of k log n, n log n, so t of 1 is 1. It is a small problem, n plus n log n. So what is the maximum term in these two? So this is n, this is n log n. So the maximum term is, this is the maximum term. So you can write big O of n log n. So the time complexity of the merge sort is big O of n log n. So this is the time complexity of merge sort. Thank you for watching this video.